Welcome back everyone to another video. So today we're just going to be going through the problem of 2 cos x sine x equals cos of x, where x is between 0 and 360 degrees. So let's get started. So the common issue with this question is that it's a little bit of a trick question, because a lot of students will come into this and then they'll just think that they can simply divide both sides by cos of x and then just simplify the problem to 2 sine x equals 1. But if we do that, then we are doing something very, very egregious, because cos of x could very well equal 0, right? So we should therefore definitely not divide by cos of x, okay? That's the most common issue encountered with this particular question. So how do we do this question now? So the key to unlocking the answer to this question is actually simply going to be to move the cos x from the right hand side to the left hand side, so we'll minus cos x from both sides, and now we've got 2 cos x sine x minus cos x equals 0. So what we can do now is just quickly go ahead and factorize that. So taking that cos x out the front, that common term, we'll get cos x out the front of 2 sine x minus 1 equals 0. And so now using our null factor law, that states the product between two or more products equals 0, therefore 1 or more must equal 0. So we can just quickly say that cos of x equals 0, or 2 sine of x minus 1 equals 0. Okay, so now quickly solving for cos x equals 0, we get that x equals 90 degrees or 270 degrees. So, whether you know that from your trigonometric graphs or you're just given numbers, or if you're just using your calculator, you should be able to get those values there. Or on the flip side, we have 2 sine x minus 1 equals 0. Let's quickly solve that for sine of x, so plus 1 to both sides, and then divide both sides by 2. We get sine x equals 1 over 2. This is actually going to come back to one of our known triangles, because we should recognize the values for the special triangle of 30 degrees and 60 degrees. It's a bit dodgy, but that will do. So we should know that there's a side length of 1, a side length of root 3, and then the hypotenuse of length 2. Okay, so if sine of x equals 1 over 2, opposite over hypotenuse, therefore x is going to be equal to 30 degrees. And again, you can absolutely use your calculator to find that value. But that's only going to be one of our possible solutions on the domain between 0 and 360 degrees. How do we find the other value? Well, we go back to our mnemonic device, all stations to central, and that tells us where each trigonometric function will be positive. So we know that all functions are positive between 0 and 90 degrees, from 90 to 180. We only have sine as positive, from 180 to 270. We have tan as positive, and 270 back to 360 is where cos is going to be positive. So now we know that we have sine of x equals a positive 1/2. That means straight away we know that we're in the first and the second quadrants. So let's quickly draw that in a little bit more accurately. There we are. So we know the first angle, the primary angle there, is going to be 30 degrees, which means that the secondary angle is going to be 30 degrees away from 180. So that means it's going to be 180 minus 30 going back. Therefore, x equals 30 degrees or 150 degrees. So those are our 4 solutions. So maybe we can just quickly cap it off at the end and just say, therefore, x equals 30 degrees, 90 degrees, 150 degrees, and 270 degrees. And if you did want to write those in radians, by the way, it would have pi on 6, pi on 2, 5 pi on 6, and 3 pi on 2. And that is how we would answer this question completely, because if we had made the mistake of simply dividing by cos of x at the start, we would not get any of these solutions over here. Okay, well, thank you very much for watching today. Please leave a like and subscribe, and let me know what other questions you have. Love to be able to help you out wherever I can. So please let me know in the comments if you have any other questions you would like me to cover, and I'll see you soon.